Hello students, this is the exit slip from lesson 1 in unit 6, the sequences unit. It was the exit slip that asked you to identify whether the sequences were arithmetic, geometric, or neither, and to identify the common difference or common ratio. For this first one thing that you could have done was examined the jumps between the numbers from 1 to 3, from 3 to 6, from 6 to 10, from 10 to 15, and we see that those jumps aren't by a uniform amount. They're not by a common difference. I would be adding 2 first, and then adding 3, and then adding 4, adding 5. This isn't adding by the same amount. It's not adding by a common difference, and it's not multiplying by the same amount. It's not a common ratio. So you would say neither. That's the sloppiest neither I've ever written. For the second one, we can observe that unlike the first one, we are skipping by a common difference. From 40 to 43, you're adding 3. From 43 to 46, you're adding 3. 46 to 49, adding 3. 49 to 52, adding 3. So you can say this one is arithmetic. And the common difference, we'll abbreviate that as CD, is add 3. All right, a little neater now. For this third one, a lot of students said that it was geometric because they indicated that it looked like it was multiplying by 4. And that works for some of the cases, but it doesn't work in every case. So I know from going from 4 to 16, you're multiplying by 4. For 16 to 36, however, you're not multiplying by 4. So that destroys your common ratio idea. So for this one, you can just state it is neither. You could have tested also for the common difference. So from 4 to 16, you're skipping by 12. From 16 to 36, you're skipping by 20. So it's not going to work. It would be neither. For the fourth question, from negative 29 to negative 34, some students said it was arithmetic with the wrong common difference. Arithmetic is correct, because what we're doing is we're skipping by 5 values. But most students that got this question wrong said that it was a common difference of 5. But it's not, because if it was 5, that would be adding 5 every time. And you can see in the sequence, the numbers are going down. So you would say minus 5. For the fifth one, this is a list of, as you might have guessed or figured out, this is a list of perfect squares. 1 is 1 squared. This is 2 squared, 3 squared, 4 squared, 5 squared, etc. The list of perfect squares is it's great, but it doesn't indicate a common difference or a common ratio. You're not multiplying by the same amount. You're not adding by the same amount. So you would say neither or neither. For the next one, it was a little bit more straightforward. From 1 to 5, we're multiplying by 5. From 5 to 25, you're doing that same thing. From 25 to 125, you're doing the same thing. So it was a clear-cut case of geometric sequence. And your common ratio was 5, because that's the number that you were multiplying by. Remember, the common ratio is the number you're multiplying by in order to get the next term. If you are scared of fractions, just cut it out. The first term is 1, then 1/2, 1/4, 1/8. In this, you had to determine whether it's geometric or arithmetic. It turns out that it is geometric. And there's a trick to figuring out the common ratio, and I showed this trick in class. What you could do is take any term, let's say 1/2, and you divide it by the term before it, which is 1. You can see that 1/2 divided by 1, anything divided by 1 is just that same thing. So 1/2 is your common ratio. As a matter of fact, if you take 1/2 and multiply it by 1/2, you get 1/4. If you take 1/4 and you multiply it by 1/2, you get 1/8. You're just cutting it in half every time. So your common ratio here is equal to 1/2. You could have written it as 0.5. Some students did. That's fine. For the last question, there are decimals here, which are certainly a little bit less scary than fractions to some. Negative 1.2 to negative 2.3 to negative 3.4 to negative 4.5. This turned out to be a common difference. It was an arithmetic sequence. And the common difference here was we were going down, so we must be subtracting. Common difference is a negative number. And every time the ones place is going down by 1, and the tenths place is going down by 1. So I'm subtracting 1 from the ones place, and I'm subtracting 1 from the tenths place. So 1.1 should be in your common difference.